So next question number 10, integration 0 to pi by 2, 2 log sin x minus log sin 2x into dx. So let's see, let I equals to integration 0 to pi by 2, 2 log sin x minus log sin 2x dx. So let I equals to 0 to pi by 2, 2 log sin x minus log of sin 2x can be written as 2 sin x into cos x. 2 sin x into cos x, right? So now I, as it is, for 0 to pi by 2, 2 log sin x minus log 2 sin x cos x is there. So minus multiplying log sin x, log mn can be written as log m by n. Log m by n can be written as log m minus n. So here we have written log sin x, log cos x, log 2. So minus multiplying minus also, minus log sin x minus log cos x minus log 2. Log mn can be written as log m plus log n, right? So I, which is equals to 0 to pi by 2 log sin x, this term, 2 log sin x minus log sin x can be written as log sin x minus log cos x minus log 2 dx, right? It is known that again integration 0 to f of x dx is nothing but f of a minus x into dx. So I, which is equals to what we can write here, which is equals to 0 to pi by 2 log sin pi by 2 minus x cos pi by 2 minus x minus log 2. So here can be pi by 2 minus x can be converted to log cos x, log sin x, log 2 dx. It is equation 2, it is equation 1. So adding equation 1 and 2, again what we get here, the LHS I plus I, which is 2i, it is 0 to pi by 2 minus log 2 minus log 2, right? Here log cos x, log sin x get cancelled, log cos x minus log cos x minus log sin x plus log sin x. These two get cancelled here. These two terms, after adding, these two terms get cancelled. So remaining minus 2 log minus log 2. So 2i, which is equals to minus 2 log 2. So minus 2 log 2 take outside this constant term, 1 into dx. So 1 can be written as x, which is equals, implies 2i, which is equals to minus 2 log 2 as it is. Inside what we get, x 0 to pi by 2. So here minus log 2, which is equals to what we get here, it is pi by 2 minus 0. So finally minus 2 log of pi by 2. So minus log 2, these two take on LHS, it becomes 2 get cancelled here, only minus log 2 pi by 2. Therefore pi by 2 as it is, log minus log 2, which is equals to log 1 by 2. So minus log 2 can be written as log 1 by 2. Therefore finally I value, which is equals to pi by 2 into log 1 by 2. Got it? So question number 11, integration minus pi by 2 to plus pi by 2 sin square x dx. So let's see, Let I equals to integration minus pi by 2 to plus pi by 2 sine square x dx, as sine square minus x can be written as sine minus x whole square minus sine x whole square. Finally, what we can write it here, sine square x. Therefore, sine square x, as it's a even function, right? So it is known that the f of x is a even function here. So integration minus a to plus a f of x dx can be written as 2 times of 0 to a f of x dx. When it is even, we can write 2 times of 0 to f of x dx. So which is property number, when it is even function, it is property number 8, integration minus a to a f of x dx, which is equals to 2 times of 0 to a f of x dx if f is an even function, that is f of minus x equals to plus f of x. So we have taken here the value, that is I as it is 2 times of integration 0 to pi by 2 sine square x dx. So 2 as it is 0 to pi by 2 sine square x can be written as 1 minus cos 2x upon 2. So again 2 to get cancelled, 1 minus cos 2x. Now integrate this, what we get, integration of 1 with respect to dx is x. Again cos 2x integration is sine 2x upon 2. So what we get here, after substituting the value, when you apply upper limit, sine, that is pi by 2, 2 to get cancelled, sine x, and similarly second term lower term is 0 only, it is pi by 2 minus of 2 to get cancelled, sine phi is 0 only. So when you substitute, what we get here, pi by 2 minus sine 2 into pi by 2, 2 to get cancelled, by 2 as it is, minus this term 0. So sine pi value is what? It is 0 only. So what we get, simply this term, pi by 2 minus 0. So the value of the given equation is pi by 2. So next, question number 12, integration 0 to x dx upon 1 plus sin x. So let I equals to integration 0 to a x dx upon 1 plus sin x, take it as equation 1. So now let I equals to 0 to pi minus x upon 1 plus sin pi minus x. So 0 to a f of x dx, 0 to a f of a minus x, that is property number 5. By using that property number 5, we can write I equals to x can be written as pi minus x 1 plus sin pi minus x. So pi minus x as it is 1 plus of sin pi minus x is sin x only. Sin 180 minus theta is sin theta. So adding equation 1, take it as equation 2. So adding 1 and 2, what we get, 2y equals to pi upon 1 plus sin x. So here both the term get cancelled when you add equation 1 and 2. What you get here, 2y, which is equals to integration 0 to pi x plus of pi minus x divided by 1 plus sin x into dx, plus x minus x get cancelled, right? So only what we get, 2i, which is equals to pi upon 1 plus sin x dx. So 2i, which is equals to pi, take outside. Now multiplying and dividing by 1 minus sin x, the numerator and denominator. So 1 minus sin x as it is, 1 minus sin x, 1 plus sin x. a plus b, a minus b can be written as a square plus b square, a square plus b square, a plus b, a minus b. So a square plus b square can be written as a plus b, a minus b. So here 1 plus sin x, 1 minus sin square is 1 square plus sin square x, so which is equals to 1 plus sin square x, which is equals to cos square x. So cos square x. So 2i pi as it is, 1 upon cos can be written as denominator taking separately here, 1 by cos can be written as, which implies 2i, which is equals to 1 by cos square x minus sin x by cos square x dx. So 1 by cos is sec minus sin by cos, 1 by sin, 1 sin by cos is tan, and one more cos, 1 by cos is sec. Sin theta by cos theta is tan theta, 1 by cos is sec theta, right? So we have converted that. So 2i as it is, pi also as it is. Integration of sec square x is tan x. Again, integration of sec x into tan x is sec x, limit 0 to pi. That is 2i as it is, pi into tan x minus sec x. What we get here? Tan x minus sec x. Tan pi and sec pi value. Let's see the value here. 2i, which is equals to, it is tan pi is 1, sec pi is minus 1, so it becomes the value 1 plus 1 is 2. So what we get here, I equals to 2 by 2 get cancelled. Finally the value of I is pi, right? So next, question number 13. Already you know standard angles, tan pi, tan 0, sec pi and tech sec 0. So next, question number 13. Integration minus pi by 2 to plus pi by 2 sine to the power of 7x dx. So let's see here also. Again, let us consider the given equation as I integration minus pi by 2 to plus pi by 2 sine to the power of 7x dx. Take it as equation 1. Now check whether it is even function or odd function. Sine to the power of 7 minus x. So sine to the power of minus x to the power of 7. So minus sin x to the power of 7 of minus sin x to the power of 7x. So it's an odd. The number is odd here, 7. So what we are getting here? Sine, therefore sin square x is what? Odd function. So it is known that if x is an odd function, what we get? The integration minus a2 plus a f of x dx is 0. So let I equals to integration minus pi by 2 to plus pi by 2 sine to the power of 7x dx, which is equals to what? The value directly we can write 0 by using property number 8. Now question number 14. 0 to 2 pi cos to the power of 5x dx. So I equals to cos to the power of 5x dx. So cos to the power of 5, 2 pi minus x. So 2 pi, 360 minus x is cos, 360 minus theta is cos theta only, therefore cos to the power of 5x. So now it is known that 0 to 2a f of x dx, which is nothing but 2 times of 0 to f of x dx if f of 2a minus x equals to f of x. 0 when? If f of 2a minus x is equals to minus f of x. So let's see here, I equals to 2 times of cos to the power of 5x dx, which is equals to what? 2 into this term becomes 0, because what we get, cos to the power of 5 pi minus x is what? Minus cos 5 x. So when you take 180 minus theta, it becomes minus cos theta. Cos 180 minus theta is minus cos theta, right? So I equals to 2 into 0 is 0 only. So next question number 15. So integration 0 to pi by 2 sin x minus cos x divided by 1 plus sin x into cos x dx. Let I equals to integration 0 to pi by 2 sin x minus cos x upon 1 plus sin x into cos x dx. Take it as equation 1. So I equals to integration 0 to pi by 2, again by using the property number 5, f of x can be written as f of a minus x. So convert it pi by 2 minus x, all the terms. So sine converted to cos, cos converted to sine. The denominator also sine converted to cos and cos converted to sine. Take it as equation 2. Adding 1 and 2, what we get in the numerator, plus minus get cancelled, it is 0. The denominator, the common term, 1 plus sin x by cos x. So anything by 0 is 0 only. So next question number 16. 0 to pi log 1 plus cos x dx. So let us consider it as I, which is equals to 0 to pi log of 1 plus cos x dx. Take it as equation 1. So I equals to 0 to pi log of 1 plus cos pi minus x dx. Again by using property number 5, log 1 minus cos x can be written as 1 plus cos 180 minus theta is minus cos theta. Therefore cos minus x minus cos x, 1 minus cos x. Take it as equation 2. Adding 1 and 2, log 1 plus x plus log 1 minus x dx. That is log 1 plus x 1 minus x. That is 1 minus cos square x dx. That is log sin square x dx. That is log sin square x dx. So 2 taking outside, logarithm property. 0 to pi log sin x dx. So 2 to get cancelled, I equals to 0 to pi log sin x dx. So take it as equation 3. So sin pi minus x equals to sin x. So I equals to 2 times of log sin x dx, equation number 4. So from I equals to 2, 0 to pi by 2 log sin pi by 2 minus x, which is equals to cos x. Alright. So sin pi minus x is sin x only. So what we are doing here, just changing the limit function. When we multiply by 2, we are changing the limit function pi to pi by 2. Let's see. Here we have pi. So now we are changing the limit function pi to pi by 2, right? So which is nothing but I equals to integration 0 to pi by 2 log pi by 2 minus x. Just multiplying by 2 and taking limit pi to pi by 2. So now we can convert log sin pi by 2 minus x dx. So 2 integration 0 to pi by 2 log sin pi by 2 minus x converted to cos x dx. Take it as equation number 5. So adding 4 and 5. Just we have changed the limit here by multiplying 2. So adding 4 and 5, 2i, which is equals to 2 taking outside common here. In the both the term 2 is common. So 0 to pi by 2 log sin x plus log cos x dx. So I as it is, 2 take on LHS, it becomes log m by n. So log m by n can be written as log m minus n, log sin x plus log cos x plus log 2 minus log 2. So now I equals to 0 to pi by 2 log 2 sin x cos x minus of log 2. So now I equals to 0 to pi by 2 log 2 sin x cos x can be written as sin 2x dx minus 0 to pi by 2 log 2 dx, right? So now let 2x which is equals to t, which implies 2 dx equals to dt. When x equals to 0, t is 0. So just substitute the value I, which is equals to what we get here, 1 by 2 outside, dx means dt by 2, dx means it is dt by 2. So 1 by 2 taking outside, log sin t dt minus 1 by 2 log 2. For dx it is 1 by 2 log 2. So I 1 by 2, this term can be written as pi 1, or you can take 1 by 2 pi 1 by 2, it is not that, 0 to pi is there, log sin t dt minus 1 by 2 log 2, right? So I, as it is, log sin t dt can be written as, which is equals to I minus, actually it is this, it is pi, it is not there, it is pi, also it is not there, it is pi, right? So pi by 2 log 2. So 1 by 2 I minus pi by 2 log 2. So 1 by 2 I plus I can be written as I minus 1 by 2 I is I by 2, 1 minus half is half, which is equals to minus pi by 2 log 2. So finally I value is what we get here, 2 to get cancel, I value is minus pi log 2. So next question number 17, 0 to a root x upon root x plus root a minus x dx. So let us consider this as equation 1. Now it is known that again f of x can be written as integration f of a minus x. So similarly here x can be written as a minus x, again x can be written as a minus x means plus x minus x get cancelled. Take it as equation 2. Adding 1 2, that is 2i equals to root x plus under root of root a minus x upon root x plus under root of a minus x. So these two terms get cancelled here also. So I dx, so again x, integration of 1 is x, a minus 0 is a only, that is if you take 2 on RHS it becomes a by 2. Very easy questions. So question number 18, integration 0 to 4 mod x minus 1 dx. So integration of I 0 to 4 mod x minus 1 dx. So it can be seen that x minus 1 less than or equals to 0 when x is closed interval 0 to 1, and again when x is greater than or equals to 0 when it is closed interval 1 to 4, right? So we have splitted this, x minus 1 equals to 0, which implies x equals to 1. So the limit function is 0 to 4 is there, so we have splitted this 0 to 1 to 1 to 4, right? So now integration mod x minus 1, integration mod x minus 1, which can be written as by using the property f of x equals to a to c f of x plus c to b f of x ds, that is property number 3. So integration 0 to 1 negative function minus x minus 1 dx plus second one 1 to 4 it is x minus 1 dx. So limit it is 1 to 4, right? It is 0 to 1, it is 1 to 4. So now x minus integration of minus multiplied inside we get 1 minus x, it is integration of 1 is x, this with this minus we have multiplied inside, so it becomes 1 minus x, right? So don't get confused, it is x square by 2 minus x minus 1 can be written as 1 minus of x. So integration of this is x minus x square by 2, right? So similarly here also x square by 2 minus x. Now apply the limit function, upper limit minus lower limit. So upper limit by lower limit, upper limit by lower limit, and simplifying it, what we get? We get the final value is 5. So next question number 19. Show that integration 0 to a f of x g of x dx, which is equals to 2 times of 0 to a f of x dx, if f and g are defined as f of x equals to f of minus a minus x and g of x plus g of a minus x, which is equals to 4, right? So we have to show that the property is there. So let's see, I equals to given 0 to f of x g of x dx, take it as equation 1. Now I equals to 0 to f of a minus x g of a minus of x by using this property number 5. So we can write I equals to f of a minus of x g of a minus of x. So f of a minus of x can be written as f of x g of a minus of x as it is dx, take it as equation 2. Now adding equation 1 and 2, LHS becomes 2i 0 to a f of x g of x plus f of x g of a minus of x, right, into dx common. So f of x g of x plus f of x taking outside, g of x plus of g of a minus x dx is there. So f of x as it is, g of x plus g of a minus x, which is equals to 4, given value here. So just substitute value 4. So when you take 2 LHS, it becomes 2 ones are 2 2s are 4, neglected. So I equals to 2 0 to a f of x dx, so which is nothing but our required solution. So next, finally, 20th question. The value of integration minus pi by 2 plus pi by 2 x cube plus x cos x plus tan to the power of 5x plus 1 dx. 4 options has been given. So let's check which is the right answer. So integration minus pi by 2 to plus pi by 2 x cube plus x cos x plus tan to the power of 5x plus 1 dx. Take it as I. So now taking separately here limits as well as its derivative functions. So it is known that if f of x is a even function, we get this value. When it is odd, we get 0, right? So now after checking the values, the first 3 terms are odd function, the finally fourth one is an even function. So neglected first 3 terms. First 3 terms are negative terms, that is x cube, cos x, tan to the power of 5. All are odd. 3 odd, 1 odd, 5 also odd, right? So we have neglected those terms, that is odd functions, 0 0 0, because if f of x is an odd function, we get directly the value 0. If f of x is an even function, we get 2 times of 0 to a integration f of x dx. So 2 times of 0 to pi by 2 1 into dx. So 2 as it is, integration of x, 1 is x, that is limit 0 to pi by 2, 2 pi by 2 by 2 pi by 2. So 2 to get cancelled, final value is 2, hence the correct answer is C. Hence the correct answer is what? It's C is the right answer. So next final question of this exercise. With this we conclude our today's lecture. So question number 21 is the value 0 to pi by 2 log of 4 plus 3 sin x upon 4 plus 3 cos x dx is. Option A is 2, B is 3 by 4, C is 0, and D is minus 2. Let's see. Take it as the given equation as I, and again by apply the property number 5, f of x can be written as f of a minus x. So apply the limit integration 0 to pi by 2 log of 4 plus 3 sine pi by 2 minus x cos pi by 2 minus x. So it becomes 3 cos x by 3 sin x. So adding 1 and 2 again, what we get? Equation 1 and 2. So log 4 plus 3 sin x upon 4 plus 3 cos x plus log 4 plus 3 cos x upon 4 3 sin x into dx. So by taking log common here, 4 plus 3 sin x by 4 plus 3 cos x into log m plus n can be written as log mn. So here these two get cancelled. 4 plus 3 sin x, 4 plus 3 cos x. So 2i, which is equals to log 1 into dx. So log 1 is 0. That is 2i, which is equals to 0 to pi by 2 log 1 value is 0. So integration of 0 is 0 only. So finally I value is 0. Hence the correct answer is C. So with this we will conclude our integral chapter, that is exercise 7.11. So if you have any doubts in this exercise, then you may ask in the doubt session. So next class we'll proceed with our next chapter, that is application of integrals. So within 4 to 5 hours I'll complete this book, application of integrals. So only 2 chapter remains now, application of integrals and probability. So within 15 to 16 classes we'll conclude the whole syllabus. Later on we'll go for revision and for JEE section, right? So till then, take care, stay at home, stay safe.